We've got a very crowded house, so glad you all could make it here. We're lucky enough to have Dr. Leonid Perlovsky, who will be speaking here tonight. He's principal research physicist at the Air Force Research Labs, and also a visiting scholar at Harvard University. And he'll be speaking tonight on cognitive algorithms for engineering and the modeling of language and cultural evolution. And before he begins, we also have Bruce Damer, who's here from all the way from California, flew in this afternoon, and he's the CEO and founder of the Digital Space Commons, the author of the book Avatars, and visiting scholar at University of Washington. And he will be speaking on a distributed collaborative A-Life project called the Evo Grid. So, Bruce?
Thank you very much. Thanks for having me in GreyThumb. We're going to establish a GreyThumb Silicon Valley or Bay Area, and we want to report that the GreyThumb London meeting went really well. I was supposed to go there, but my father ended up in the hospital, so I didn't go. But Justin wanted me to report they had 15 people, and they're holding another one on March 25th. So GreyThumb London is launched. So congratulations to everybody. I only have 10 minutes, so I'm just going to zip through this. Give you a little bit of background for myself. I did a lot of the original graphical interfaces in the 80s, pull down menus and things when they barely worked for Xerox. And I founded a nonprofit called the Contact Consortium in 1995, just as virtual worlds were starting on the internet. And one of the subgroups that we founded in 96 was called Biota. And many of you know about the Biota podcasts that Tom Barbalet does, which is a really great community resource. I'm going to give you a little background on Biota, and then I'm going to talk about the latest Biota project, which is the Evo Grid project. And a little bit more background. I wrote the first book on avatars and held the first conferences on avatars and stuff in the mid-90s when it was starting. And I founded a company that does simulation for NASA, open source simulation. And if you're interested in ancient computers, when you're out in the Bay Area, come and see me, because I've got a barn full of 500 old computers, from Cray ones to all the Apple prototypes and the OSI Challengers and whatever you name it. So all of this is at these websites. If you're interested, they pretty much are linked off of damer.com. So about Biota, we established Biota in the summer of 1996 to go beyond where the artificial life conferences were going. The artificial life conferences were becoming very, very drilled down and technical, and we felt that the visionary aspects of artificial life were being lost. So a group of artificial life people like Chris Langton and Tom Ray and whatnot, we founded the Biota Conference series, and we held 4 events. And I'll just give you a little bit of a run through those. The first one was a very interesting event. We went to the Burgess Shale in Canada. We climbed to 8,500 feet on a mountainside with this 60-person conference to the Burgess Shale, and that's me with Tom Ray on the shale. And there's a few scenes from the conference. There's a fossil there of an Atoia from the Burgess Shale. So it was an inspiring first conference. It was in 1997. The second conference, we had it in Cambridge, England, and these are some of our speakers, Richard Dawkins and Douglas Adams and whatnot. And so that was the group of people at the time that were doing artificial life or interested in artificial life, the Biota Conference series. Whoops, sorry. And we did a project called Nerve Garden, which was at SIGGRAPH 97, where people extruded and grew virtual plants, L-system plants. So Biota's not only done conferences, it does projects and sponsors projects, but usually with bigger groups. Now what we're doing is the podcast, and I invite you to go to biota.org and listen to some of these incredible interviews. And we've got old speeches by Richard Dawkins and Douglas Adams and Tom Ray and Carl Sims and all those people. But we have new live shows every week that you can call in. It's a call-in podcast show that's recorded. It's very cool. So it's a really good community resource. The new initiative, and it's an idea that sort of occurred to me one day last year, which was if we could somehow create a grid on which all of our artificial life efforts could communicate and work in a common grid or with a common protocol. The idea just occurred to me one day last year, and I started to ask people if they thought this was viable. And And Carl Sims and Tom Ray basically pointed out that their initial artificial life work was grid-based, i.e. the evolving creatures on the connection machine. That was a grid of processors, 2,000 processors on the CM2 or the CM5, I think he was using. And then Tom Ray used a network of machines to do Tierra in the early 90s. So what would an artificial life grid look like in the 21st century? Well, it would be very Web 2.0. It would be very semantic-based. Let's pop over here. This is the vision for an artificial life grid. I came up with the name EvoGrid because I could get the domain name evogrid.org. And there was a Python project called EvoGrid, which was a Python framework for artificial life. So I got in touch with that guy, and he said, yeah, you can use our framework. You know, I've been building it for a year. I thought, well, it's got to be called EvoGrid. So there you have it. But this is the vision for the EvoGrid. Imagine an L-system forest, a herbivore simulation, and a carnivore simulation all developed separately without having its own graphical front end. And each object in the separate simulations would communicate locally or via the network using some kind of protocol. And next, picture more of the 3D front-end view portals with all the bells and whistles that visualize what's going on in the engines and traffic, putting any local area into a coherent scene. Of course, this is the common method used in Second Life in any massive multiplayer environment. This is how they do it, folks. So if you could do that, you could create a true evolution grid or EvoGrid, if you will. Then you're not, of course, limiting your simulations to one processor or the tyranny of one scene graph's rendering step clock. And then you could have people specializing. So people who are good at doing brains will do brains, and people who are good at doing neural nets are doing neural nets or sensor processing. And then if a new developer came into the community, they would develop their own simulation, maybe an L-system plants or good landscape simulation, and they would work on it for 2 years, and maybe they'd lose energy or they have to go to a different day job or something, and their simulation would continue as a citizen of this grid. Because one thing we've seen in the last 20 years is some of the efforts get abandoned and they become fossils. And it's a shame that they become just fossil relics. So that's the idea of the EvoGrid. So no project need die and become extinct. So this is the discussion. We've started it's an email copy group, and this was Jeffrey Ventrela's proposals for the elements of the EvoGrid. If you took any one of your simulations and ripped it down and made it into the atomic pieces, then you'd get physics, genotypes, sensors, brain, actuators, geometry, rendering, etc. And this is we're just starting to talk about it, and we'd really love to have you guys part of this discussion. And what would the next steps be for a alpha 1.1 low? Maybe to talk about and make a real simple, almost like a Tim Berners-Lee type simple protocol where a couple of your simulations can talk to each other and then can talk to a visualization environment. And what about, tying together Noble Ape and a GreyThumb project with Reve and just seeing if it can work? Say, could Reve visualize 3 or 4 of the projects, 3 or 4 of your virtual creatures talking to each other in a grid format? And maybe could we do something by the end of this year to show that it can be done? Not something overdone, but just a test project. If you're interested, you can sign up on the mailing list. The Biota podcasts, we're talking about them every week practically now, and the evogrid.org site has links to everything. One of the projects I worked on for NASA last year was the design of a human mission to an asteroid. Just to give you an example of EvoGrid. If you get Popular Science, the whole thing ended up on the cover in November. I designed this system which has a ring of airbags and has tethers, and it's designed to let a crew actually land on a low-gravity environment of an asteroid and go on EVA and do things safely. And I designed all of this about 1.5 years ago, and then our team at Digital Space did the engineering and did the visualizations of it. And so this is what it looked like, the Popular Science version, but you can see the astronauts are sort of floating there like they're scuba divers because you have really low gravity. But one of the things that NASA said in the future is if we're going to send robotic missions to an asteroid, they have to be able to walk and manipulate things in very low gravity environments. This would be a great application of an EvoGrid because you would create an evolution scenario kind of like a Carl Sims Creatures, low gravity, and try to evolve things that are optimally designed to explore the surfaces of an asteroid. So that's an example. So the thing is, we will all evolve much faster and much better together if we can get our simulations working in this grid. And you can reach me at bruce@damer.com and go to evogrid.org, and there's just a bare bones page there. We need help if anybody has logo design skills or any kind of skills. But I'm planning to work on this for at least the next 3 years, and we have some of our NASA people interested in proposals and doing kind of research funding for this as well in the next couple of years. And that's it. Thank you.